Everyone, April 1st. April 1st again. Alright, had a good day today. Traveled a little bit, went to the Chinese American culture and history museum. Yeah, I mean, they had a Bruce Lee exhibit. It was quite nice. Very interesting. Alright, so let's get it going. We got a medium today. I don't think I've done this before. Successful pairs of spells and potions. Nice. I like the title immediately. We're given two positive integer arrays, spells and potions of length n and m, where spells I represent the strength, spell potion j represent the strength of the potion. You will also give integer success. A spell and a potion pair is considered successful if the product of their strengths is at least success. Return an integer array pairs of length n, so length of this, where pairs I is the number of potions that will form a successful pair with the ith spell. Okay, so this right, pairs I is the number of potions that will form a successful pair with this. Isn't that the same as what we had yesterday? It does feel the same, right? So we just need to sort potions, and everybody is larger than 1, right? So we sort the potions, and we will we're asking for, but hold a second, m and n is 10 to the 5th, so we cannot go one by one. Now we can sort this as well and use the same technique, right? Let's say we sort spells, okay, and then we sort potions, and then we, from the small, right, we want to find the successful pairs at least success. That be larger than equal to. So we can go from front, find the first one that is larger than this, and then everybody else is, and then we move on to the next one, and this must be larger or equal to. Then we just keep moving, but if it gets larger, we might be able to get smaller. Oh yeah, we should need to get smaller. We should go down. So we should go the largest first. All right, we go the largest, right, and then we go from here, find the first one that's smaller, then everybody else fits, and we go one smaller. Now that doesn't make sense. Think again. What if this is small to large? How about this from large to small? So we go we find, it doesn't really matter, it's the same thing. We'll find the first one that's bigger. How about we go small to large? We'll find the first one that's bigger and everybody else is good. So this is first one's bigger. And then we go the next one. So we have to go down the other direction. We'll go down the other direction, right? And then we go even larger. I thought we can go in the same direction. So you are saying this one go large to small, this one goes small to large. So we have the biggest one, so we go small to large. Find the first one that is larger than success. Okay, then we stop, and then we go someone smaller, right? So we have to try, and if it works, because it's smaller, right? So if it works, then that's the first one, because the previous one doesn't work. But if it doesn't work, we just keep moving. That makes more sense. So I will sort spells from large to small. Okay, and I'll sort, so different sorting. So I will sort spells reverse equals true, and I'll sort potions regular. Okay, and then rest will equal to 0, and I will say I and j equals 0 and 0. Okay, and for I in range, actually I don't need I think j is sufficient. And we can use for s-ing spells. Okay, then we say while potions j multiplied by s, if it's smaller than success, then j plus equal 1. All right, and we keep going until the first one that it's larger equal than, then we jump out, right? When we jump out, what do? We do res plus equal to len potions minus j. Then we go to the next spell, right? And j doesn't change. We try it. If it's smaller, we keep going. If it's larger equal, then we just keep going. And then we'll return res. And if that's the case, we can actually move them to this. And let's test this. So basically, this is the same idea as that guy's solution. Of course, you can do this using binary search, but I'm pretty sure this is the better solution. I mean, it's exactly the same as the one we had yesterday. I think this week, at least for now, it looks like we're testing. This is like 2sum or 2product. It's the same thing, right? It's the same thing. All right, let's take a look. Spells, potions, success. Oh, I forgot. Successful pairs. Potions, success. No, potions, spells. Oh, list out of range. Oh, of course, list out of range. Jeez. Have to smaller equal to lamp potions. Potions. Right. What are you doing, man? Come on, man. It asks for the it is correct. Right? It is correct, but it's asking for the number for each one. Ah. Okay. So it's slightly okay. We have to change it. So it's sorted spells. Okay. What do we need? We need to do this for is in enumerate, because I need to create it first and then I have to put it back in space, right? And then we're gonna do how about s and I, right? S and I for this, and then we reverse, and then we'll have to s and I. Now the result is not a count. Result is going to be 0 times len spells. Okay, that's the result. And blah blah blah. We don't have the result here. We have res I equals this. Then we return. Lordy. My bad. Okay, this should be good. Sorted. I just kept making mistakes. Oh my goodness. This is sorted spells. There we go. My God. Undergoing so many iterations. I think finally shall be good, right? What else can you test? Well, how about we do, I don't know, I have to do 7. How about this? 5, 5, 5. Let's say 3, 3, 3, 3. All threes. And then we do 7. Yeah, just, try it out. See how it goes. Yeah, it looks fine. Alright, looks fine. Alright, let's give it a shot. Oh, I was going to say why it takes so long. Okay, so it's good. Yeah, I mean, it's the same. You want to write a binary search? I can actually write a binary search. I'm gonna write a binary search solution as well. So this one goes first. This is following yesterday's idea, right? This follows yesterday's ideal of 2 pointers, right? 2 pointers. We sort spells from large to small, and then potions from small to large. And then we iterate, and for each spell, we go from small to large in potions, right, until their product is larger or equal to success. Now, when we handle the next spell, since it is smaller than the previous one, we don't have to restart the search in potions. Instead, we continue from the previous stoppage, right? Yeah, and then just we continue with this, continue this until we handle all spells. Now this problem is a little bit more complicated because the returned value has to be the number of valid pairs per spells in its original order. Therefore, we have to handle that as well. But it is not difficult, that hard. All right, so we have O and log n, that's for the sorting, plus OM log n, log m, that's for the potions. And then we have how do you consider this? M plus n, right? That's what I think. That's m plus n. All right, let's see. Sorting. We're gonna try this one as well. Sorting on 2 pointers. N log n, m log m. Yep, that's right. Overall, take this. Yeah, that's fine. All right, let's try the other solution as well. Okay, what is the other solution? The other solution is, so this one, the solution, this one, we will try the binary search solution, right? Which only requires us to sort potions. It's good and bad. Yeah. No, it's actually simpler. Anyway, from bisect import bisect what? We'll get the division, right? And we do integer division, so we get something slightly smaller, right? We get something slightly smaller, so we're gonna do bisect right. Now we're gonna say we're gonna sort portions, and the rest will equal to 0 times. Actually, we can do rest equal to this. Say for s in spells, q equals success divided by s, right? And then index equal to bisect right portions q. So this towards the end, which means res need to append. Okay, so one more thing. Actually, we have to, it's always complicated here. So if value is within, then it's going to be here, right? And we're just going to do len of potions minus this. That's fine. But what if we have an extremely small, which becomes 0? Well, if it's 0, that's the entire thing. It's actually fine. What if it's too large? That would be 0. Huh? Yeah, that's fine. That's fine. So I think we can just say res.append without issue. .append len potions minus this, right? And then return res. Oh my god, this actually might be even easier. No, it is easier. Ooh, what happened here? I do not know. All right, we'll have 3, 1, 2, and 16. That's 8. 8, 8, 8. Ay, ay, ay. Now we should do bisect left. Yeah, I don't know why I say bisect. Hold on. Because if it's divisible, it's bisect left, right? If it's not divisible, we get something smaller, and we should do bisect right. Ooh, that is right. Darn it. Hold on. Let me think. I think I need to do. Hold a sec. I need to do this. QR. Okay, that's the div mod. Div mod success and s. Okay. And q shall equal to. If we have the remainder, then we just do q. If q is equal to 0, now r is equal to 0, q need to minus 1. So q minus equal to r is equal to 0. There we go. So pay attention, right? Pay attention to the case where success, s divides success. Okay, we put this one in here and give this a shot. Okay, looks good. It's faster. It's faster. Okay, what's this runtime? Well, on log n, no, actually om log m, that's the sort, plus this is on log m. That's why it's om plus n log m. Yeah, it makes sense. All right, so we're done with this. Good. That was good. Okay, I have some time. Keep moving. 2564, substring exclusive all. You're given a binary string. I can actually close this one. You're given a binary string s and a 2D integer array queries, okay? Where queries I equals first and second. For the ith query, find the shortest substring of s, the shortest substring, whose decimal value, val, yields second I when bitwise exclusive or with the first I. You can't even. Yeah, I think this is not complicated enough. I think they should make the sentence even more complicated. I think I understood. They could just put this one out here. You don't have to describe it. You know what? Yeah, you should. You should describe it. Anyway, so we want the shortest substring S whose decimal values, wait, in binary or in, no, not in binary, decimal, right? So the shortest substring of this, exclusive OR with this, equal to this. The answer to the ith query is the end points of the substring, or -1 if no such substring exists. If there are multiple answers, choose the one with the minimum left. Return an array answer where answer I equals this is the answer to the ith query. Substring, okay, so query 0 to 5. For the first query in range 0, 1, 2, we got 101, and 101 translates to 5. And 5 exclusive OR with 5 equals to 0. Hence the answer to the first query is 0, 2. In the second query, we have 1. So we need something exclusive OR 2 equals 1. And is the exclusive OR like commutative, or so we need to find something, right? So x and exclusive OR 2, which is 1, 0, need to equal to 0, 1. So can I exclusive OR on both sides 2, right? Actually, I'm not sure. Is it associative? If I can exclusive OR 1, 2, because a value exclusive OR itself is 0. Actually, is exclusive OR, let's see, is exclusive OR commutative? It is. Commutative and associative. It is commutative. We're not going to go through this. I just need to know it's commutative. So if it's commutative, right, then our equation is x exclusive OR 2 equals 1, and I can exclusive OR on the right side for both 2, right? And then commutative, so on the left is x exclusive OR 2 exclusive OR 2. That will be 0. So left side is x exclusive OR 0. So left is x. And the right side is 1 exclusive OR 2, which give us 1, 1, which is 3, right? So therefore, we want to find a 3, a 1, 1, right? So the first occurrence of 1, 1, which is here. So 0, 1, 2, 3. So it is a question. So we can know immediately, right? We know immediately. We just need to exclusive OR these two values to find a value, and we will get this binary into a string, and then we need to find a substring in here that matches that. And we need to do this match as fast as possible. Well, Python has substring matching. I mean, consider this is in the text, in the context, right? In the test context. So I think, I mean, actually, I'm not sure. Do we do substring matching? Okay, it's a.index. Can I say 0, 1? 0, 1, 2. Yeah, you can. So I'm not going to waste time to implement my own substring matching, which you can use KMP to do so, but I definitely don't think that's the right way to do so. So for this one, we will do, as usual, the old method, right? The old method of what? Of we have a res equals this, and for each queries, right? So for, as I say, AB in queries, C equals A exclusive of B, and we need to find its binary. Oh Lord. Is it format the best way to do so? I always forgot. Format. No. F string. F string 5. 2B? 02B? Yeah. What if it's just B? Yeah, so we don't have any. Yeah, we can do that. This is, I think, is the best. So C equals F. We will do this, and we will do this B. My God, it didn't even work. It'll be confusion. Lord, Q and Q1, Q2. Let's do this. Q1, Q2, and then Q1 exclusive or Q2. You know what? I'm not sure. I'm not sure if it's going to work. Hold on. No, we can try. Hold on. We need to say, actually, AB equals, I don't know, 8. All right, 19, and F. A exclusive of B. Yeah, it works. It works. That Q1, Q2 is fine. And then we just need to say S dot index this, right? And what if we cannot find? Right? What if we cannot find? Lordy. A dot index, let's say 2. Oh, that is gonna be slow. Holy crap. We might be slow just for, you know what? You know what? Try. You might time out, man. Seriously, you might time out. Try. So we try res dot append. No. Index equals s dot index, right? Except res dot append -1. If we get it, then res dot append index and index plus, right? Plus. Oh. And then Q1, Q2, that will be, doesn't matter, let's say T, right? T equals this. And then will be T, and that will be length T minus 1. I will return res. Okay. Not sure. We have to search every single time. Well, depends. Maybe it will work. Maybe it will time out. If it times out, we have to think something else. Yeah, not only time out because of the searching, because every time we basically search from the start, but also because Also because we have this exception. As queries. Yeah, I'm not worried actually. Yeah, I know it passes here, but let's give it a shot. Let's hope it doesn't time out. Ain't that simple, man. Ain't that simple. Okay, so but anyway, it's just a substring matching issue, right? A substring matching. Maybe we need to do some DP into it. Substring matching. I mean, it's hard to decide like what the issue is. So how can we match the substring easier? I do not know. Well, I would imagine that index is a very fast way to match. Yeah, the first occurrence. I might as well need to copy this one out. Wait. Am I slow? Oh, wow. Oh, holy cow. Holy cow. What the hell? What the hell? I need a result. Holy cow. Jeez. Come on. It didn't give me all. Didn't give me all the result. Maybe all of them are -1. Maybe that's why it's timing out, because all of them -1. Okay. Okay, so I don't want to write KMP. I do not want to write KMP. But it's a substring matching problem. If you don't write KMP, you run into this issue of not matching. Dear God. I was just thinking about KMP. I think KMP need to live inside my useful snippet. You know? Because I'm just telling you, I cannot write KMP like from scratch. But even if you do KMP, right, that will take ON to run. Or ON plus M to run. And when you check every query, and every query needs to take this to run. And we can have a dictionary, so if something has checked before, then we don't have to run again. Ugh. That was ugly, man. That was ugly as hell. That's just ugly. Let me think if there is any in a way we can, maybe we can prepare. That might be an idea. Maybe we can prepare it. We prepare a dictionary. I'm just trying to find a way of avoiding using KMP. That's basically what I'm trying to do. So maybe for each t, right, we can find all binary numbers associated now with the same length. Okay, we go through S, and that might actually be that might actually work. Okay, so what we do is we can have a what are we gonna have? We're gonna have the length, right? Not really the length, is the number, right? The value. So for this value, it's going to be the first occurrence. The first occurrence of all the values. So we should say value occurrence map. Okay, so it'll be this. So we don't do this. Okay, we don't do this. What we do is we get the t, and we'll also have, say, checked. Checked is gonna be a set. Okay, so we say if len t is not in checked, then we just sliding window through S. Sliding window through S. Now what do you suggest? Well, what I suggest the sliding window will be well, it's smaller than length t, which is plus one until it's equal to t. Now until we add it, it's larger than t, then we will get a front. Wait, how we plus it? And if it's equal to, we will no, we shall plus it, and if it's too much, right, if we plus one, then we exceed, then we will no, I don't like it. What I want to do is get rid of the front. Next time we add, right, and then we do and get rid of the front. Get rid of the front. Can we get rid of the back? Now it's a substring, it's the same. Okay, let's just get rid of the front. So we will add. When it's equal to, right, we will calculate, get rid of the front. Next one we'll add. Okay, so we'll say for I in S, in len S, we have to start with the window. Okay, the window. So while len window is smaller than len t, window plus equal to si, and then when it's equal, we come out, then we do bin, right? Bin 1000001. No, integer, int base is 2. There we go. Actually, I'm not sure if it's right. That should be 7. Okay. So we will say the first time that occurs. So t, and then we say n equals what? int this window and 2, right? And we need to see if n is not in val occurrence map, then val occurrence map n dot append the current index is I. No, we end in I. We end in I. Then we start should be I minus len t, right? Minus 1. So that's that. But if it's in it, that means we have handled it already, so we don't do it again. So the first time that we encounter, you know what? That's actually not precise because it could be like 00001, right? That's actually not right. So what we need to do is if okay, hold on. So the start is this. We have the start. And then we have the start and is equal. So start equals to this, right? This is the start. This is the start. Now we say if val this dot get n. Well, we can do math.inf. If does not exist, right? Dot get this 0 is a start. If it's larger than st, then we say val this not append, this shall equal to st to I. All right, that's that, and then we go back up. No, win equals win 1 to the end. So we skip the first one, and we go back up. We add 1. That's actually not right. This is not gonna work. I need to be 0. This has to be while I smaller than ln s. If it is, I plus equal 1, right? So we can do another loop in here. So equal to 1, blah, 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 until we put 1 that will equal to this. We come out, get a win, get a starting position. Really? Minus this? No, plus 1. Get the starting position, do this, wing is this, and then I plus equal 1 here, right? I plus equal 1. And then we go back up, and then if this is actually, do you do y plus 1 here? Jesus. If it's smaller, we just, if len is smaller, we'll add I and I plus equal 1. And go up, I plus equal 1, blah, 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 until we're good. And it will come out, I will plus equal 1. Then come back, this smaller than this. I don't know, man. No, I don't like this. I do not like this. Hold on. I like that. This is actually plus. We shall say if this or we can do this and we say if it's equal to, right, then we do this. We always add. If it's not, we keep adding. If it's equal to, we will do this and then remove the first and we add. That one looks more likely, and I don't need this. All right, if len t is not being checked, then we do all of this. Once we're done, we say checked dot add len t, which means this length has been checked. And yeah, okay. Then we are going to say, right, if len t has not been checked, then we'll check all the lengths, right? And now we're gonna do is to find the value of t, right? The value of t. So it's res.append, and we want to know if this value is inside. Oh, hold on. If it's inside, yeah, it will always be inside if it's smaller. If it's in there, right, no matter what we need. Actually, I have the value already, right? I don't like this. Okay, let's do this. Val is equal to this, okay? Binary val is equal to this. And all the t is binary val, right? Len binary val. This is also binary val. Check.add binary val. And the rest.append val occurrence map.get val. If I cannot get it, -1. Alright, let's try see if this one works. Int object is not iterable. Of course it's not iterable. Okay, almost. Let's take a look. I got 0, 2, I got 1, 3. 0, 1. Lordy. So which means I need to get rid of all the zeros at the front. Okay, that's not too big a deal. We can left strip. We can strip all the zeros. Strip all the zeros. I shall first strip its zeros, right? So this is what we get. And then, let me see, left strip zeros. So a equals 0, 0, 1, 1, 1, okay? So a dot l strip 0 is this, right? So this minus this plus 1's front, and is the starting position, plus what? Plus this is the window, right? We're looking at current window. Window dot left strip 0 and length of this, right, left strip 0, and length of window minus this, that's the total number we need to skip, which means if I'm here I need to skip 2. 1, right, 1, 2, 1, 2. If I skip 3, 1, 2, plus 1, plus 2, plus 3. So I need just plus this. And if you notice, this and this can cancel. So I can cancel these. That become plus 1. Minus, okay, hold on. Right? I is at the end, right? And I want to find, so we need to move to the front. I minus its left strip. Left strip, so it's this. Yeah, it makes sense. So I can remove this. Actually, we're going to do this. +1 here. Now we pass. Now we pass. Okay. Let's try this. This is way more complicated than what we had expected earlier. See if this one works. Slow. Right? It's slow, but it works. It's much slower than and the official is 700 milliseconds. So it's about half. But definitely faster than earlier, right? What how much did we earlier done? Actually, I never tried earlier. Can we find an earlier version? Yes. How long does this one take? That's just lots and lots of exception. Of course it's gonna time out. Yeah, it's timeout. So from timeout to 1000. Yeah, let's try it. Hold on. We're gonna do this. Right. Run it again. All right, try this. Huh. It's not correct. A 4-3. Dude. A 4-3. We have an issue. That is not right. Yeah. God forbid. How'd you get a 4? Let's see. We will append, right? We'll say. So are you telling me the ST become larger than I? How is that even possible? It is possible. If the length, if it's 1. But still, if I is here, hold up. My answer is what? 4-3. 0, 1, 2, 3, 4. So it shall be 3-3. It's a 0. Dear God. Because I do left strip 0, it'll become nothing. So we have to avoid that. Right? We have to avoid that. Which means the current n is a 0. So if it's a 0, we have to do it differently. Right? Current n is a 0. If n is a 0, okay, if n is a 0, we shall get the left, right? Oh my God. Okay, if n is equal to 0, start shall equal to I minus len win plus 1. Else, it shall do this. Jeez. Okay, one more time. We're getting close to 1 hour. If it cannot do, oh. 0, 2. My lord. It's a 0. It's messing me up. It's the 0 that's messing me up. I knew it. I knew it. I knew it. I know what's wrong. The 0, 2. It should be 0. Okay, so what's messing me up is I do this. If it's equal to 0, then yeah. All right, how about we handle it differently? All right, how about we do this? If it's equal to 0, right, then start equal to this, and how about we do this? Start and end. Okay, start equal to this, end equal to the same. So start equal to end equal to this. Otherwise, start end are equal to this and I. Then we do start and end. How about this? Yep. Guess we pass. What more do you have? Throw at me. I already 3 down. The next thing might be time limit. Now we pass. God. All right. I don't have more gana. Continuing, so I want to read about the a better solution tomorrow. But it was quite a journey, huh? I think it was 3 rounds. Okay, so let's document. So the first attempt, right? The first attempt is the most naive, right? Where we find the... Okay, hold on. First things first. We can do Q1 exclusive or Q2 to find the value, right? Find the value to search in S. We turn the value into its binary string, so the problem is converted, right? Is converted to finding the index, right, of the first occurring index of the first occurring substring in S. Now, the naive solution is to use s.index, right, binary string. That's the naive solution. It might be fast. It might be fast if the can be found, but if it cannot, Python throws an exception. Now we have one test case where I think all the queries will throw exceptions, and since Python's exception handling is very slow, we TLE. Alright, so the next attempt is to cache, right? To cache all the values we have, encountered, right, during matching. And this is basically an avoidance of going through KMP. Anyway, so for each target binary str, we sliding window, right? We sliding window S to find all available substring of the same length. We compute their decimal values and check if the current window range has the smallest start. We save, right, the smallest start in a dictionary, right? In a dictionary, in a dict, with the key being the value. And this way, for a value for a binary str in the future, right, whose value we have searched before, we can simply obtain it from the cache. Now the tricky part is with zero, because when we encounter zero during sliding window, it might be multiple zeros. It might be multiple consecutive zeros. Right. This we have to handle differently. This is the trick. This is zero must be handled differently. Actually, what's the runtime? So we have to do every single query, and then for each length we have to go through the entire thing. But if it's the same length, then we don't have to do this entire thing again. So, which means at most we have to do 10 to the 4th. So 10 to the 4th, how many times? 10 to the 4th is, let me see, 10 to the 4th. That's 2 to the 5? No. 10 to the 4th, no. 13, 14, 14. 10 to the 4th. So 14 times, okay? So at most we'll run this check 14 times. I could have run it first. Right? I could have run it first. I could have built the cache first. Well, since the max value, oh no, it's 10 to the 9th, so 32, right? Since the max value in query is 10 to the 9th, which is 2 to the 32, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, 31. No, 30. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 30. It's 2 to the 30. Right, 2 to the 30. At most, we run the sliding window 30 times. So it will be O M and 30 times plus plus 30 times n, okay, where m is len queries, n is len s. Okay. Oh, check the solution tomorrow. The better solution, I mean. Make sure the checked length will not be checked again. Should not be checked again. Key is value. Here some val. The value is the range of its first occurrence in S. Value, binary value. If it's not been checked, we'll check it. Which is we set up this. This is a sliding window. Right, it's a sliding window. We get the value. If it's 0, we handle differently. Otherwise, we get a start and end. And if the current is larger than, then we do this. And then we clip the first. Keep going on. Okay, just add it. And then we will do, yeah, okay. All right, I will see you guys tomorrow then. Adios.